In this video, we're going to review the process of the formation of an ionic bond, and we're going to use a very simple ionic compound, lithium fluoride. And if you were given these two atoms, lithium and fluorine, you might not know off the top of your head that these two atoms are going to associate by forming an ionic bond. And that's okay. What you do have are the tools that we have discussed in previous videos and in the online lecture modules to determine what type of chemical bond atoms are associated by. And really the first step that you're going to use to determine what type of bond various atoms will form is really by drawing out the electron configuration. This is probably the easiest approach. And we're going to draw the electron configuration for both atoms. So I'm going to start by drawing out the electron configuration for the lithium atom. We've used lithium atom in a previous video. We know that it has an atomic number of 3, so we do recognize that it has 3 protons and 3 electrons. And again, I'm not going to be concerned about the protons and neutrons in this particular video. I'm only going to concern myself with the electrons and their placement in the electron configuration in their shells. And so I'm going to draw the inner shell for lithium, and because, actually let me move that for a second because I'm going to run out of room as I draw the second shell. So for the first shell, we're going to place that pair of electrons up on top, and we're going to fill in both electron positions in that inner shell. Now we still have 1 electron to place, and we're going to do that in the valence shell, or the outermost shell. This shell has 8 electron positions, but we're only going to be utilizing 1 for lithium, so I'm going to fill 1 of the top pair. And by looking at this electron configuration, you can say to yourself that yes, the lithium atom is a reactive atom, and that is because it has an unfilled valence shell. It has an incomplete valence shell. It has 7 open positions in that valence shell. All right, let's look at the fluorine atom. If we look at the atomic number for fluorine from our periodic table, we'll see that fluorine has an atomic number of 9, which means it has 9 protons and 9 electrons because the atom is electrically neutral. We're going to start by placing the first 2 electrons in the innermost shell. And once we fill that shell, we're going to move out to an outer shell. In this case, this outer shell is going to be the valence shell. I'm going to place my pairs of electrons around that atomic nucleus first, and then we're going to go ahead and fill the rest of them in. And using the same rules that we used before, I'm going to place electron number 3, 4, 5, 6, 7, 8, and 9. Okay. And then hopefully you can see that fluorine also has an incomplete valence shell, making it a reactive atom. Now, since both atoms are reactive, they both have a goal of wanting to fill their valence shell. It's what we refer to as the octet rule, and having that stability. And so when we look at these two atoms, we want to look to say, okay, how can both of these atoms fulfill their goal of filling their valence shell? And the easiest thing for these two atoms to do is actually transfer lithium to transfer its 1 valence electron over to the valence shell of the fluorine atom. And I'm just going to designate that transferred electron in red so we can kind of remember where it came from. Now, I think it's obvious when you look at fluorine that it has completed its goal of having a completed valence shell. It has that octet rule. Now, lithium has transferred away its one electron in its valence shell, so we can now erase this valence shell, that second shell, and now the inner shell becomes the valence shell, and this atom has also completed its goal of filling its valence shell by having 2 electrons in that inner valence shell. Now, interestingly enough, these are no longer atoms once that one valence electron was transferred, and instead they are referred to as ions. And ions are defined as a charged atom, so an atom that has an unequal number of electrons and protons represents an ion. So I think it's really easy to look at if we just write out the charges for the protons and electrons that are in each of these ions. So lithium, we know, has 3 protons. So it's going to have 3 positively charged protons associated with it. Remember, the number of protons gives the atom its identity. So in this transfer of this one valence electron from lithium to fluorine, we didn't change the number of protons in either atom. Okay. All right, but after the transfer of the electron to fluorine, lithium now has 2 electrons, both negatively charged. And if we cancel out the opposite charges, you're going to see that what we're left with is a positive charge on the lithium ion. So lithium is a positively charged ion. It has 1 more proton as it has an electron, and this is what we call our cation, a positively charged ion. Okay. We can do the same thing for fluorine. It will just be a couple more charges to designate. So fluorine has 9 protons, and again, that's not going to change. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it has accepted an electron from the valence shell of lithium. And anytime we transfer electrons between atoms, we're always transferring electrons from the valence shells, never any of the inner shells. And we now have 10 electrons in the fluoride ion. And I can represent those by a negative symbol: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I cross off those canceled charges, what we're left with is a single negative charge, which means that we have 1 more electron than we do protons, and that fluoride ion takes on a negative charge, which makes it an anion. Now, the ionic bond forms between the attraction of oppositely charged ions. So the positively charged lithium ion is attracted to the negatively charged fluoride ion. And again, if these atoms come in close enough proximity to one another to transfer an electron to fulfill that octet rule and fill the valence shells and generate these oppositely charged ions, they're in close enough proximity to attract to one another. And that's ultimately what forms the ionic bond from these chemically reactive atoms. So hopefully by working through the process step by step, you have a better understanding of how these ionic bonds are formed.